on the standards for mathematical practice in a language we all understand. My name is Janine Ferrara, and I am the Director of Product Management for all Sadler's Mathematics and Digital Products. Today we will be walking through the standards for mathematical practices in hopefully a language that you will be able to understand, and I will be providing you with questions and strategies that you'll be able to take back with you in the classroom. What I would like to say just before we get started is that everybody's microphone is on mute. So should you, which means that you can hear me, but I can't hear you. So should you have any questions throughout the presentation or after the presentation, I would appreciate it if you would just type them in the chat box, and then I will address them at the end of the presentation. So let's get started. So today, as I mentioned, I will use examples from our Sadler's new Common Core Progress math program to familiarize you with the standards for mathematical practice. And I hope that you all know that as part of Common Core, there are actually three entities in Common Core. They're the Common Core content standards, which we all know and love. That's the first thing that we looked at when the standards were released in 2010 to see what we are and are not going to be teaching at our grade level. Then there are the standards for mathematical practices. They are the thinking and the process standards which students should be applying when learning mathematics. And shifts in mathematics are what should be happening in instruction, what shifts should be happening in the classroom to effectively implement Common Core. So if you think of the shifts as focus, coherence, and rigor, I'm sure you've heard those three terms before. Those are what we call the shifts in math. And what Common Core is saying is that these three entities have to be working together in order for you to successfully implement Common Core. But today we are going to focus on the standards for mathematical practices. And so there are 8 of them. They are common through K through 12, and they're not meant to be seen as a checklist where today we're going to be making sense of problems, and tomorrow we're going to be reasoning abstractly and quantitatively, but rather they should permeate all instruction. And you may address each one of them every day, but I'm sorry, you may hit 1 or 2 of them a day, but you will never really be addressing all 8 of them at once. You will only be addressing several of them. And I'm going to take you through each and every one of them. I'm going to walk you through each and every one of them, show you how you would be addressing them in isolation, but just know that what Common Core is saying is that you're going to be probably applying several of these when teaching mathematics. So what does Common Core look like in the math class? Well, Common Core wants our students to be collaborating. They want a math classroom to be no longer a talk and chalk. We want our students to be active learners, taking an active part in the learning process. So we want them sharing their ideas. We want them discussing their thoughts and using math academic vocabulary to explain and justify their reasoning. We also want them to be conceptualizing math. I mean, that's the major goal of Common Core is we want students to really make sense of math and be able to apply it in their real world, whether it be their careers or college after they leave high school. And then explaining and justifying is a real key point, a real key ingredient, I should say, to the Common Core math classroom, because this is the way you're going to be able to get into the insight of students' insight, whether they really understand the Common Core state standards or not. And one way to, in order for you to have students collaborating, conceptualizing, explaining, and justifying, we need to engage students in the learning process. So students need to be aware of, from the very, very beginning, what their expectations are. What are the content standards that they're going to be held accountable for, and the standards for mathematical practices. So these standards are not just for us to know as educators, but for students to know. Students need to know that mathematical practice 1 is make sense of problems and persevere in solving them. And one way that we could engage students in the learning process is through the SWABOT strategy. And I'm not quite sure if everybody has heard about this strategy, but this is a strategy where the teacher tells the students what they will be learning. So she identifies what they will be learning in the classroom, and the students repeat that back. And I have a really short clip from the teaching channel. And if you're not familiar with the teaching channel offers a lot of wonderful professional development videos to help you implement Common Core. And this is just one strategy that I think that you could take back with you and use in your classroom to help engage students in the learning process. So it's about a minute. I'm going to play this quick little video for you. It's on the SWBOT strategy. SWBOT.
So this is something that has been just really effective in our classroom. We have on our whiteboard a box that says SWBOT. SWBOT, 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 SWBOT. Students will be able to capitalize, proper noun, SWBOT. SWBOT stands for students will be able to. And it states what our objective or our learning goal is for a particular lesson. SWBOT. I will say and write the objective, and students will repeat it. Identify. It sort of has a rhythmic tone to it. It just signals students' brains, okay, this is our goal for the next 15, 30, 45 minutes. What do I capitalize? The more we could be transparent with students, the more we model metacognition and we get them thinking about their own thinking and learning, we also help them become more effective.
So SWBOT, I hope you could hear that. It was kind of low on my end as well. But SWBOT is a great strategy I think that we can implement. We need to be able to engage students in that learning process and let them know what they're being held accountable for. Here is an example from one of our pages in our Common Core Progress Math program, where the beginning of every lesson, we identify the Common Core state standard that is being addressed in every lesson. And in the Teacher's Edition, we do spell out what the standard and the objective is of the lesson. Objectives, as mentioned in the video, must be specific, they must be clear to students, and they must be measurable. So it's really important to identify the objectives right in the beginning of the class, of the lesson. Also in our Common Core Progress program is what we have is a progress check. And the progress check is, I like to think about this as a self-assessment. What it does is it identifies how the standards unfold across the grade levels. So what should the students be bringing to this grade level in this particular unit? What are they going to learn, and what will they learn in the future? And this is the coherence behind the standards, because the standards are definitely tied together. They all work with one another, and there is coherence behind the standards. And this progress check really helps make learning objectives or goals clear to students, and it's right in the beginning of every unit. So let's get into the mathematical practice standards. So now that we've identified what our learning goal is today, is we will talk about these standards for mathematical practices and have real life, hopefully, applications for you to take back to the classroom. So the first standard is make sense of problems and persevere in solving them. What you see on your screen here is the 4 problem-solving steps, and how these 4 problem-solving steps are critical for students learning, not only in math, but across all disciplines. These 4 steps should become a habit of mind for students. They are for us as an adult. We read, we plan, we solve, and we check almost every problem that we're faced with. But we don't stop and say to ourselves, let me read the problem carefully. Let me identify the relevant and irrelevant information in the problem. Let me identify what the question is asking for. And then let me plan an entry point into solving the problem. We do this automatically because it's a habit of mind for us. So these 4 problem-solving steps need to become a habit of mind for our students. So it's really important that we emphasize these 4 problem-solving steps in every day in our math classroom, because we want to be solving real-world problems in our math classroom every day. And by following these 4 problem-solving steps, students will make sense of problems. And we want students to know that if they plan an entry point one way into solving a problem, if that entry point does not work, we want them to persevere. We want them to know that try another way. Don't get stuck on that dead end. So persevere in solving that problem. So we want them to make sense of the problem by reading the problem carefully, planning that entry point, solving the problem with a strategy that they've identified in their plan as their action plan, and then checking to make sure the answer makes sense in the context of the that answers the question and makes sense in the context of the problem. So in our Common Core Progress program, we have a problem-solving model in our Foundational Skills Handbook in the back of the book. We outline the 4 problem-solving steps that students should be following throughout the program. And we also give them sample lessons that they can use to practice those 4 problem-solving steps, because Common Core wants problem-solving to be integrated into every math lesson. So they want the standards to be taught with real-world problems. So you'll find that in our new Common Core Progress program that every lesson begins with a real-world problem that introduces the skill or concept of the lesson. So how do you encourage students to make sense of problems and persevere in solving them? Model for students how you made sense of the problem. Students come into the classroom with a blank slate. They don't understand what it means to make sense of a problem. So if you model your reasoning, how you made sense of the problem, it'll help them understand what your expectations are of them. So to help them understand how they will make sense of the problem. Have students describe the problem in their own words. If students are able to understand the problem in their own words, you will understand whether they know what the question is asking for, if they've made sense of the problem. I like this third bullet here where it says ask students to identify what they know that is not stated in the problem. This is identifying hidden information is a great problem-solving strategy that students need to understand, and that strategy of identifying hidden information will help students make sense of problems. Encourage students to make a diagram or a table or a drawing, a picture of the problem. Again, that will help them make sense of the problem. Number 2 is reason abstractly and quantitatively. You will read in the standards, you'll see these terms, decontextualize and contextualize. What does that even mean? Well, what Common Core wants that to mean is that they want students to go from the problem, take the math out of the problem, understand that math, and now put it back into the context of the problem. So in this case, we're talking about Bart has 7 packages of pencils. Each package has 6 pencils. How many pencils does Bart have? Well, let's take the math out. What does 7 and 6 really mean? Students really need to know the how manyness of each number in order to make sense of this problem. So again, students move from a real-life context to the mathematics and back to the context. So we need to know, students need to know, make sense of the quantity. So here we're breaking apart 6. This happens to be a grade 3 lesson, but back in kindergarten, students are learning how to compose and decompose numbers, right? They're making sense of quantities. So in order for students to understand this lesson, they have to make sense of the quantity, make sense of the math, pull the math out of the problem. Do I understand what 6 is? Yes, 6 is a combination of 2 and 4. And then put it back into the context of the problem so students are able to answer the problem. Here's another example. This is a grade 5 example, and this has to deal with fractions. And they want to know how much seaweed salad did Zoe and her sister eat with lunch. Again, they have to make sense of the quantities in the problem. So they have to make sense of 2 and what 1/5 means. That 1/5 means that 1 equal part of 5, 1 equal part of a whole that's divided into 5 equal parts. So making sense of the quantity, putting it back into the context of the problem, helps students reason abstractly, make sense of the quantity. So how do we get students to encourage, we encourage students to reason abstractly and quantitatively? Let's ask them to draw a representation of the problem, or ask them to explain what it means when we say 1/2, or when we say 5/10, what does it actually mean? And so we want students, again, this collaborative classroom, we want to start asking questions, getting students to explain their reasoning. And if they explaining can be with words, explaining could be with drawings as well. Number 3 is construct viable arguments and critique the reasoning of others. We want students to be able to have rich student discourse throughout our math class. We want them to have open discussions where they're sharing ideas and sharing their strategies. So in our Common Core Progress program, every unit opener begins with an essential question, which sets the focus of the unit. This essential question is the big idea for the unit, because I will be showing you that there are essential questions in every lesson, which will actually, we build knowledge for the unit essential questions. But essential questions are key for students in understanding the Common Core state standards. So as I mentioned, not only we have an essential question at the beginning of every unit on the unit opener, and again, that sets the stage for the unit, and then every lesson in Common Core Progress begins with an essential question where we want to get students talking about mathematics. And then we follow it up with the Connect presentation. Our Connect presentation always has an explain exercises where it'll help you get into the student's thinking process. Again, I can't stress enough that it's so important that students share their thinking, explain their reasoning, and construct viable arguments. That's going to be important for students to conceptualize math. As well, in our guided practice section, every guided practice section includes a Think, Pair, Share feature where we want students to think independently. You want them to think independently first, then either pair up with a partner or a small group and share their ideas. And this, again, will encourage, facilitate, I should say, rich student discourse in your math classroom. And then again, in our independent practice, we're always asking students to justify their answer to construct viable arguments. Reasoning and explaining, I should say explaining and justifying, we should have students be doing that every day in our classroom. They're actually two different tasks. Explaining and justifying do not mean the same thing. Explain means what you did procedurally, and justify is why it works mathematically. And I'll show you what that means in an example. So how would you compute, and of course I would ask you to turn and talk if we were together in a group, but how would you compute 3 divided by 1/5? Most people would say, I flipped 1/5 and multiplied 3 times 5 to get 15. 3 divided by 1/5 is 15. And that's an explanation because that's what you did procedurally. But that's the way I know I was taught, but that's not the way Common Core wants it taught today, or that explanation. A more Common Core explanation would be tying the explanation, I should say, the justification back to the meaning of the operation. So by the meaning of division, and there are 2 meanings of division, I have one whole divided into 1/5 equal parts. So I know there are 5 1/5 in one whole. I have 3 wholes, so I multiplied 3 times 5 to get 15. There are 15 1/5 in 3. This type of explanation is a more detailed explanation, a more I should say this justification is one that you can really get into students' insight, whether they really understand the meaning of operations, because here they'll understand the meaning of division and they'll understand the meaning of multiplication as well. And if they really understand the concept, we really need to push students to really conceptualize with their, and the way we get them to conceptualize is by not only reasoning but also explaining their answers. And reasoning and explaining and justifying type questions help move students cognitively up the depth of knowledge chart, up that level. So most questions that we ask are level 1 and 2, but we really want to push them up to that strategic thinking where they're tapping their higher order thinking skills, their critical thinking skills. So we really want them to be reasoning and explaining and justifying. When they're justifying their strategic thinking, you're moving into those level 3 type questions, and we're not just focusing on recall and skills and concepts. So in our Common Core Progress program, in our Common Core review, every unit ends with a Common Core review, which we correlate every item, every question that's on the Common Core review to a depth of knowledge DOK level, and that you'll see here in our Teacher's Edition. So how do you encourage students to construct viable arguments and critique the reasoning of others? Well, here are some great question starters. You can ask, well, what do you think about what Mary said? Do you agree? Why or why not? Why or why not? That's a great question to get students to start constructing viable arguments and critiquing the reasoning of others. Can you explain what Mary is saying? Because if students can explain what somebody else is saying in their own words, then you know that they've conceptualized it. Can you explain why his or her strategy works? How is your strategy similar to Mary's? And can you convince the rest of us that your answer makes sense? These questions are great conversation starters to help implement Common Core, the Standards for Mathematical Practice number 3, construct viable arguments. Number 4 is model with mathematics. And model with mathematics, what Common Core wants us to do is expand our definition of modeling. When we first think of modeling, we think of tangible, concrete manipulatives like counters, place value models, connecting cubes. But what Common Core wants us to do is think of modeling as modeling math with words, modeling math in the real world, applying math in the real world, modeling math with drawing a picture, modeling math with a diagram or a table or a chart. I have this image up on my screen here, and I got this image from 101qs.com, and I'm not quite sure if you are familiar with this website, but 101, it stands for 101 questions, and it's a great website for you to be able to bring math, real-world math, into your everyday math lesson. What they do is every day they post an image or a video, and the question is, what's the first question that comes to your mind? Well, depending on what grade level I teach, I could think of many questions. If I'm in kindergarten, I could say how many are on the left, how many on the right, how many, is the left more than the right. If I'm in the upper grades, I could talk about gallons and half gallons and quarts. There's so many different questions that you could think of based on this image. And this is a nice way that you could model mathematics in the real world with every math lesson. So just know it's a great site. It's a searchable site, so you could go on the site, search by grade level, search by content. But I thought I'd bring this resource to you because I really enjoyed searching this site, 101QS, 101questions.com. In our Common Core Progress program, every unit begins with a real-world opener, which is colorful and engaging, and it helps students see how math is applied in the real world. And we have question starters for this real world opener in the Teacher's Edition because we want to tap students' prior knowledge just beginning a unit. Ask them what they know about the unit's content. How do they think fractions are used in the real world? And here we're just showing one instance, and this is the most common one. I know pizza is often used to introduce fractions, but beginning every unit with a real-world application and conversation starters is a nice way to help students to see where students are in their thinking process. As I mentioned earlier, we begin every presentation, every lesson with an understand. What we've done is we've taken the Common Core State Standard and we've broken it down into bite-sized manageable pieces. We've broke down that standard into different skills and concepts. So we've broken the standard down into bite-sized pieces. But here we're showing how the use of modeling. We're modeling from the word problem, we're modeling with an equation, and we're also modeling with a pictorial representation. So we want to make sure that students make the connection from the pictorial, from the concrete, I should say, to the pictorial to the abstract. And here's another model that would be in this same lesson. And again, you could see how we started with a comparison with an unknown product, and now this talks about the comparison involving addition. This lesson is on using multiplication and division to make comparisons. And again, as I mentioned, we want students to be able to make connections from the pictorial representation to the symbolic and as well as the concrete, because that's going to help our students lead to fluency. So how do we encourage students to model with mathematics? We ask students, can you make a model to represent that problem? How could you use symbols to represent what's happening? So I have a word problem. How can you use symbols? How can you use numbers? How can you make a model to represent what's happening? Can you write a number sentence, a drawing, a picture? So these are nice, again, questions that you can ask students to help them model mathematics in your classroom. Number 5 is use tools appropriately. Use appropriate tools strategically. How can you select the appropriate tool to use and use it correctly to solve problems? Again, just as we need to expand our definition of modeling, Common Core wants us to expand our definition of what a tool is. So think about tools as not only tangible tools, as those concrete manipulatives with rulers and protractors and grid paper and calculators, but also non-tangible tools. Problem-solving strategies are a non-tangible tool. So when students are going to solve a problem and they use an appropriate strategy to solve that problem, that's the appropriate tool. Or whether they use a computational strategy, maybe they decide that they're going to break apart a number or make 10 to compute. Those strategies should be seen as a tool. So we want students to be able to use those tools properly. So as I mentioned earlier, tools are really important in our lessons. We consider a number line as a tool. We use these tools to teach our lessons as well. Consider counters and drawings as tools as well, and not just the typical protractors or rulers. So how do you encourage students to use the appropriate tools? Ask them questions. How did you use that tool? How did using that tool help you solve that problem? Get them to talk about what tool that they used. And if you didn't have access to that tool, I really like this question. What other one would you have chosen? So what's another tool that you could have used to solve that problem? And that question really gives an opportunity for rich student discourse, because maybe I'm using one tool and another student is using another tool. So we want students to, openly share their ideas and discuss their solutions. So I really like that second question. So number 6 is multifaceted. It's attend to precision. It's probably one of the most important standards for mathematical practices in addition to standard number 1. So standard number 1 makes sense of problems and persevere in solving them, and number 6, attend to precision, really should go in hand, because we want students to be solving problems, making sense of problems every day, and then attending to precision when solving those problems. And attending to precision, we want students to be able to use the correct academic vocabulary when solving problems, explaining their reasoning, justifying their answers. So here is, again, a lesson in Common Core Progress where right at the beginning of the lesson we identify those words to know. What words students should be held accountable for in the lesson, so that they're able to use that language when reasoning, when explaining and justifying their answers. And in the Teacher's Edition, we have additional support for the words to know for the teachers. We give them additional information on those words to know. Labeling of graphs is another facet of attending to precision. It's really important that students be precise and label their graphs with titles, with labeling their axes and the scale as well, because we need to make sure that students know that without any labels, their graphs have no mathematical meaning. And students will be deducted points in the new assessments should labels not be included in their graphs. So we stress the importance of labeling their graphs throughout our program. Another facet of attending to precision is including units. It's extremely important to include your units when solving every problem. So once you solve the problem, always answer it in a complete sentence, including units. So here the answer is just not 7, it's 7 minutes. We need to stress to students that they need to include the units when answering every problem. And in our program, we answer every problem with a complete sentence. So again, stress that it's 7 inches, it's 7 minutes, it's 7 apples, when in the lower grades, those apples would be considered a unit. So it's not only measurement units, but it's any unit that's being addressed in the problem. So how do you encourage students to attend to precision? Here are some really good questions to ask. What new words did you use today, and how did you use them? Right? That's getting at the academic vocabulary. We want them to use that academic vocabulary in their explanations. Why? So that it becomes a habit of mind for them. We want that to become, these words to become a habit. Just like our 4-step problem-solving model is a habit of mind for us as adults, we want them to get in the habit of using those academic vocabulary words every day. How does your answer connect to the question? Does it make sense? Right? Did you label your graph? Did you label your units? Did you include units? Does it make sense in the question? And again, can you convince the rest of us that your answer makes sense? Again, going back to mathematical practice standard 1, tying them together. 1 and 6 should always be used together. Number 7 gives teachers pause, look for, and make use of structure. But again, we want students to see that there is structure in our number system. There's structure in the algorithms. And so here is where we're introducing the division, the meaning of division, where there are 2 meanings of division, where one you're finding the number of equal groups and the other one you're finding the number in each group. We need students to see that structure, see that it's the number in all divided by the number in each group is equal to the number of groups, and then the number divided in all divided by the number of groups is equal to the number in each group. We need to see that repetitively, that there is structure. And then we also tap students' prior knowledge with our remember feature. These little features show up periodically throughout our program to make sure students remember what they have learned. So how do you encourage students to look for and make use of structure? How can you prove to me that you have the right answer? Well, if I've done this over and over and over again, I know it works. That rule works. That equation will always work. So we want, again, this one's a little tough for students and teachers to get their heads around, but we want students to see that there is structure. When we're composing and decomposing numbers, that there is structure in the number 8. That 8 consists of 8 and 1 and 7 and, 8 and 0 and 7 and 1 and 6 and 2. There's structure. There's structure there. So how can you prove to me that the answer is always 8? Show me that pattern. And then speaking of patterns, number 8 is always looking for and expressing regularity in repeated reasoning. And I kind of put this little box here at the top right to say, if it's regular, it's MP8. If it's repeated, it's MP8. If it's both regular and repeated, it must really be MP8. So patterning is always you're always going to be addressing mathematical practice standard 8 whenever you see a pattern. And again, I'm just showing you an example of our Common Core Progress program where we address the MP8. So how do we encourage students to look for and express regularity in repeated reasoning? Ask them, do they see a pattern in the process they're following? And if they can identify a shortcut, then they've identified the pattern. The goal is to identify that shortcut. So remember a couple of slides earlier where I asked how would you compute 3 divided by 1/5? And most people would say I flipped it and multiplied. That's the shortcut we want students to find, but only after that they've conceptualized how to divide a whole number by a fraction. So we want students to get to those shortcuts through patterning, through repeated reasoning, but only after they've conceptualized. So I've taken you through all 8 of these mathematical practice standards. In the interest of time, we're almost done. I only have a couple more slides left. I know we're supposed to keep it to a half hour. I'm 5 minutes over. I apologize. But again, like I said, you will not be addressing them one by one. It's not a checklist, but you will be addressing a combination of them. As I mentioned, when you're problem solving, you're addressing mathematical practice 1, you're addressing mathematical practice 6, and you may be using a model, mathematical practice 4. and you may be using appropriate tool, the strategy, which is mathematical practice 5. So in your lessons, you will be addressing more than one mathematical practice at a time. So my suggestion to you, I always encourage our teachers, again, ask students, engage students and parents in the learning process. Let them know about the standards for mathematical practices. As you have posters hanging around your classroom that emphasize different areas of math, I encourage you to put posters up of the standards for mathematical practices so students know what they are. They're familiar with them. It becomes a habit of mind for them. And ask them questions like, which practice standard did you use today? Which is your favorite? Which is your least favorite? And why? And then you're going to get students talking about these practice standards. So with that, I hope that you understand the standards for mathematical practices a little better than that Common Core has explained them in their documentation, which tends to be a little high level. And if you are interested, I hope you are interested in our Common Core Progress Program for Mathematics. It is a K-8 program. You can definitely go to sadler.com/preview CCP for Common Core Progress to request any samples. And with that, I'm going to open it up to any questions that you might have. And I will end with that with the Common Core Progress Program, it is a comprehensive program that comes with a consumable work text for every grade level, a comprehensive teacher's edition with lesson plans and strategic strategies at point of use to teach the standards, free online components with the purchase of the program, a web-based assessment program where you can customize assessments or assignments based on a Common Core state standard, and an assessment booklet, a benchmark assessment booklet. So with that, I'm going to open it up to any questions that you might have. If you have any additional questions, always please feel free to email me. So questions? Okay, I see some of them coming in. Just one second. Okay, so this is a program. The question is, what grade levels and what is the cost for the Common Core Progress Program? So again, this program is available for kindergarten through 8th grade. It's available currently right now for kindergarten through 5th grade. 6th grade through 8th grade will be available at the end of March. And it's structured with obviously the more student edition you purchase, the cheaper it is. So for 20 plus more copies, it's $14.95, and for $1 more, you would get the package of the student work text plus the progress monitor, which has 4 benchmark assessments in it for each student. Okay. Well, I want to thank everybody for attending this webinar. I hope it was informative for you. Please watch our website on Common Core Progress. We will be doing additional websites. I believe the next one will be on the shifts in mathematics. So again, if you have any information or need any additional information on our Common Core Progress program or the Standards for Mathematical Practice, please do not hesitate to contact me. Have a good day. Thank you.